Hello everyone. In this video, we are going to consider transformers. To help us understand how the transformer works, we first have to understand something called mutual induction. On the screen, we see an electromagnet placed near a coil. An electromagnet is a magnet in which the magnetic field is produced by an electric current. It consists of a wire of several turns wound around an iron core. It can be turned on or off. So once the switch is open, it is off, but if the switch is closed, it is on. It is therefore not a permanent magnet. There is a coil situated close to the electromagnet. When the electromagnet is switched on, the iron core becomes magnetized, and this sets up a magnetic field. The magnetic field that is set up cuts the neighboring coil and induces an EMF into the coil. This can be detected by the galvanometer. You can equally check the video on electromagnetic induction to learn more. This happens for a fraction of a second because once the current reaches a steady value, the magnetic field no longer grows or it becomes steady, and so no cutting of the neighboring coil occurs. This effect, where when the electromagnet is switched on, causes current to be induced in a coil situated close to it, is referred to as mutual induction. And can you guess what mutual induction is an example of? Yeah, you guessed it, electromagnetic induction. This can be compared to you bringing a magnet close to a coil. As the magnetic field lines cut the coil, EMF is induced. But what will happen when the electromagnet is switched off? The electromagnet will lose its magnetism, and as a result, the magnetic field lines will collapse. As they collapse or pull away, they will again cut the neighboring coil and again induce EMF into it. And this can be compared to pulling a magnet away from the coil. There is also an example of mutual induction. So even though the neighboring coil is not connected to a source of current, it gets EMF induced in it. The transformer works using the same principle. The transformer is an electrical device that transfers electrical energy from one circuit to another by electromagnetic induction. It consists of an iron core that is usually laminated. Wound on the iron core are two coils or windings. The primary coil is connected to the input voltage, and the output is tapped from the secondary coil. It is important to note that the transformer works with AC, that is alternating current, not DC or direct current. An alternating voltage will set up a changing magnetic field which can constantly cut the secondary coil. Using direct current, the current will flow in only one direction, and as a result, the magnetic field that will be produced will be steady, not changing, and so there will be no interaction of the field lines with the secondary winding, and so no EMF will be induced. Let's consider then how the transformer works. When alternating current flows through the primary coil, it sets up an alternating magnetic field in the iron core and around the primary coil. As the field lines grow outward from the primary, they cut the secondary coil. The changing alternating field induces an alternating voltage in the secondary coil. The iron core aids in channeling the magnetic field generated so that as much of it as possible cuts the secondary coil. The secondary voltage can be calculated using the equation secondary voltage over primary voltage is equal to secondary turns over primary turns. The turns here refers to the turns of the coil. Using symbols, we have Vs over V subscript P is equal to N subscript S over N subscript P. A transformer can either be a step-up transformer or a step-down transformer. A step-up transformer has more turns on the secondary than the primary, and as a result, the output voltage or secondary voltage is greater than the input voltage. A step-down transformer has fewer turns on the secondary than the primary, and as a result, the secondary voltage is less than the primary voltage. In a circuit, a transformer is not drawn as you see on the screen, rather it is drawn using an electrical symbol as shown. A transformer is said to be 100% efficient if there are no energy losses. All input power is converted to output power. Mathematically, we can write power in primary coil is equal to power in secondary coil. Power is given as voltage V times current I. Therefore, we can write V subscript P times I subscript P is equal to V subscript S times I subscript S, representing a power on both sides of the transformer, that of the primary and the secondary. Rearranging gives us IS over IP is equal to VP over VS. From this relation, we see that for an ideal transformer, current and voltage are inversely proportional. Therefore, if voltage doubles, current is halved. In actual fact, transformers are not 100% efficient because the coil or windings have some resistance which causes them to heat up, and so then energy is lost as heat. Heat is also lost through the ion core. This can be reduced by laminating the ion core. Thanks very much for watching. Please be sure to subscribe, like the video, and comment. See you in the next presentation.